Hello, this is John Schubert, 760-846-8830, JOHN Schubert @ that's SPIRENT.com. And this is a really fast video that I put together to show if I'm doing a back-to-back test, inherently there's two different links that I'm testing. The outbound link from, in this case, a C1 to a switch or a device under test. It could be a switch, a router, anything. And then the return path. So the question was, if I just want to test one link, can I do that? And so this is to show that, yes, you can. That's what we currently have configured and running, and to show briefly how to set it up. So in this case, we've got a C1. It's a C1 with 6 ports. 2 ports are optical, which are not reserved, so that's why they show offline. The remaining 4 ports are an Ethernet card, of which I only utilized 2 of the 4. So what you can see here is the lab server, or I'm sorry, the lab router's host name. So this is my own internal home lab. I have several switches. So this is John's lab switch number 3. And then if we were to expand that out, you would see the actual Ethernet ports on the Cisco 3560. And so what we did first is I went in and I created devices. So the devices that I told it to configure are 4 devices per port. And then I gave them each the next subsequent port or the preceding as its default gateway. So I assigned port 1 as .2, and I told it .3 is your gateway. So then the next device on port 1, I assigned it to 3.3, and I told it, okay, use .2 as your default gateway. So in effect, this is going to tell 2, send everything to port 3, that's your gateway, and 3, send everything back to 2. And then I just repeated that for another pair. So 4 goes to 5, 5 goes to 4. And then I repeated it another pair of times. So the first 4 devices are on port 1, and the second group of 4 devices are on port 2. However, this being done, I went in and I created traffic to only create traffic on port 3. So port 4 is not doing anything. So there's endpoints, but there's no traffic generator. And I did that because I wanted to keep this simple so that you can see down here, my transmit and my receive are identical. So all right, so here we are. We have the application up. If you've previously connected, you will see the most recent IP addresses and the ports that were reserved on that particular instance. So on the first occasion, I did just the fiber, which was ports 1 and 2. And the second occasion, I did all of the Ethernet ports. So this C1 has 2 cards into it, SFP 2 port and a 4 port RJ45. So just to show, you can either hit connect to chassis here, you can hit something that you've already reserved recently, or you can also go up to your chassis for reservation, and I believe there's one more, chassis for reservations. And then here you'll see the most common ones. So we'll go ahead and do this just to show if you're doing something from scratch. If there's nothing here, you can go in and say connect, create. You just come here, type in the IP address, 192.168.1.175. In my case, yours should be different. Hit OK. And it just queried the C1. It sees that it's got 2 NIC cards. The first one, ports 1 and 2. That's fiber, back to back. The second NIC card are ports 3, 4, 5, and 6. And then you can see in this case, I've configured my Cisco 3560 with a host name of John's Lab SW3 because I have 3 switches. This is the third. And I gave it a host name and the domain. I'm sorry, not the host name, but I gave it a domain of Shub. So when it queries from Spirent TestCenter, it's going to take the host name dot domain and populate that here. So if you're set up to a lab where there's host names that can resolve, this can make it highly easy to figure out what's going to what. The 4 ports that are Ethernet are 100 meg, and the 2 SFPs are 10 gig. So dual speed will do 1/10. Right now they're configured for 10. So for simplicity, I'm just going to reserve ports 3 and 4. However, you'll note that when I do this, it's going to actually say all 4 are now unavailable. So regardless if I want 1, 2, 3, or 4, it's going to configure all 4 ports. When I say configure, I mean reserve. At this point, we're going to go to all devices and click add. So what we're doing is we're creating hosts. We're not emulating routers. So we'll do ports 3 and 4. This is what I mentioned just a few moments ago. We're just doing hosts. If we're doing routing, switching protocol testing, then when we enable these, then you can see there's a drop down. So for the sake of just creating traffic, we leave these alone and we hit next. So we can do IPv4, IPv6, we can dual stack it. This is Ethernet over copper RJ45, so that's why that's highlighted and we can't change it. You can do VLAN headers. That's outside the scope of this example. So this is the out-of-the-box normal configuration. I can create 1 device per port, and then it's going to create a stream block based on that 1 device for that port. And so this is just a logical grouping of statistics. And this will make a little bit more sense here in a minute. So if I have 2 ports and I'm putting 1 device per port, it's saying, okay, you have 2 devices and then you have 2 stream blocks, 1 on each port. It's just taking all the traffic. Now I could create a stream block with UDP traffic and unicast of a different type, or multicast and TCP and have that be a separate stream. And the reason why you use different streams is so that you can measure, identify, and isolate performance of specific types of traffic. In this case, since we're just testing a link, we're not needing to get that granular with the capability. So what we're going to do is we're going to create 4 devices per port. Now, what I want to do is I want to have 1 device per stream block. So it's going to treat each of those 4 and track them individually. So 4 devices per port. I have 2 ports. So it's telling me, okay, I'm going to have 8 devices all together. I can name them here if I want to give them a custom name that makes it easy to read it. Just for my own sake, I like to do 10.0.0.0.2 for this example. And we're going to go into here and we're going to change this to 0.0.0.1. As soon as that goes valid, this goes away from being read. We want to step per port and hit OK. All right, so let's double check. 4 devices, 8 total. Rest port, 1 per port. We're going to increment them. Let's see, IPv4 2. So we're going to tell it to use .3 as its default gateway. So it's going to show us what it's about to configure. Now I'm going to go back in and manually change this. So this doesn't bother me that it's not even remotely correct. All right. So we're going to make the first device. This is port 3, physical port 3 on the C1 10.2. And we're going to tell it, send your traffic to the default gateway at .3. So we're going to go to the next device. And we're going to say, all right, you are .3. And I want you to send everything to .2. Now we're gonna do the same thing here. So we got 2 and 3. So now we'll do 4, 5, and just so that we don't have duplicate IPs in our config, I'm gonna go ahead and go through and do all these, even though I'm not gonna touch port 4 just because I wanna make this easy to follow. All right, so we've just configured everything. 2, 3, 4, 5, 6, 7, 8, 9. So we're telling 2, go to 3, 3, go to 2. We're gonna tell 4 to go to 5, 5, go to 4. 6 is going to go to the next port. 7 is going to go to the preceding port. 6, and we're going to tell port 8, I'm sorry, dot 8 gateways to 9 and dot 9. Whoops, go back to 8. All right. So, all right, everything's good to go here. Device count, 1 device, and hit apply. If you've made any mistakes, it should figure out if we used duplicate IPs. So if I had 2 that were .5s, at this point, as it's going through the validation step, we would see an error in the log. All right, so it's running through, it's 94% complete. And here we go. Now, if you see these counting up, that's because I have STP turned on that router. I'm sorry, on the layer 3 switch. So you're seeing it's trying to resolve any loops in its routing. So up top, we've got port 3, and now what it's doing is it's launching the results viewer. I'll go ahead and minimize that since we haven't ran any tests, so there's no results to view yet. And all right, so again, 4 ports or 4 devices on each port. Now what we're going to do is we're going to go into traffic generators, and we're going to create traffic. So go to tools, wizards, traffic, create traffic, next. All right, so we want to tell everything on this port. You can talk to this port. We're going to make everything bidirectional, and we're going to add this. So now we can see that everything can talk to everything. 1 can talk to 5, 2 can talk to 6, and etc. So now we're going to go to next. We're going to leave this alone. Whoops, I missed one thing. I need to allow port to generate traffic to itself. All right, so now we're going to go next. Then hit finish. Start traffic. And we can see that our stats are nearly identical. So what it's doing is it's transmitting out port 3, and then the switch is realizing that the destination is right back to it, the same port. So I didn't turn on the traffic generator on port 4. Over here, you can see that there are basic traffic that's going out, but when we look at the stream, we only created and turned on the traffic stream on the 1 port. So now we can go through and we can look at the different, we can look at the performance of that specific link. So we know we have 17 millisecond latency round trip. So divide that by 2, and that's the actual link latency. So that's between the C1 and the 3560. Some of that latency, of course, is going to be the device under test, in this case, the Cisco 3560, hitting the layer 2 translation table and then routing the IP right back